Hi guys, I'm Dr. Vanessa Mendez. I'm a board-certified gastroenterologist and internal medicine specialist. Today we're going to talk about gut health and the gut microbiome, one of my favorite topics. As a gastroenterologist, I may be biased, but I do think that illness and health really start in the gut. So what is our talk gonna be on today? So we're gonna provide an overview of the digestive system and its role in contributing to health and illness. We're gonna touch upon the endocrine and immune functions of the digestive system. We're gonna talk about the gut microbiome and get a little bit specific. And we're gonna end on how to optimize the gut microbiome and our health. So the gastrointestinal tract acts as the largest endocrine organ in our body with over 30 hormone genes. The gut produces more than 30 neurotransmitters that communicate with the brain, and it houses 70% of our immune cells, which are found in the gut-associated lymphoid tissue and is part of the innate immune system. That's the first line defense when there's any pathogens in our environment. Our digestive system is intimately involved with all the systems within our body, and its effects are far-reaching to all of our organs. And not just through the food and nutrients we intake, but also through the production of its own chemicals, enzymes, and hormones. Our body, especially our gut, is its own ecosystem. Our gut is home to trillions of microbes in the forms of viruses, bacteria, fungi, archaea, which are single-celled organisms, and microbial eukaryotes. There are 150 to 200 times more microbial genes than human cellular genes. So in terms of genes, humans are only 1% human and 99% microbial. Although there's microbial commonality between humans, each of us has a distinct microbial composition that acts as our own unique fingerprint. Just like the various organisms in any ecosystem, these tiny organisms called microbes, gut intestinal flora, play a crucial role in keeping us healthy. A healthy gut environment is a breeding ground for beneficial microbes. They act in many ways to contribute to our health or disease, including creating chemicals that are beneficial or pathogenic to multiple organ systems, but also by crowding out pathogenic microbes that cause disease. Studies have shown that a healthy microbiome is involved in many different diseases, including but not limited to heart disease, hypertension, diabetes, cancer, inflammatory bowel disease, and other autoimmune conditions, and even Alzheimer's, Parkinson's, and depression. In terms of evolution, our microbes have played an essential part in getting us to where we are today by living symbiotically with us since the beginning of time and evolving with us through time. We are as dependent on them as they are on us. We give them food and we host them in our bodies. What they eat, we eat too. In terms of evolution, our microbes have played an essential part in getting us to where we are today by living symbiotically with us since the beginning of humankind and evolving with us through time. We are as dependent on them as they are on us. We give them food, what we eat, they eat too, and they in turn regulate many processes within our body. The immune system is a perfect example of this coevolution. Our immune system has evolved alongside the microbiota, creating a relationship where they coexist and assist one another in maintaining homeostasis or balance within our bodies. Some key functions of our gut microbiome include defending us against harmful microorganisms, regulating our immune system, degrading toxic compounds, digesting foods that we're not able to digest ourselves, and facilitating the absorption of minerals. They also synthesize essential vitamins such as vitamin K and folic acid and amino acids, which are the building blocks of proteins. They produce beneficial products called short-chain fatty acids as well. So we're going to talk a little bit about that in a second. Our gut microbiome development really starts in utero. When a baby is inside a woman's body, we believe that there's some cross of the gut microbiome through the placenta. Then the baby's microbiome really gets its first big dose at birth as it passes through the birth canal or as it encounters the skin and open air if born through C-section. It continues to develop through breastfeeding or formula feeding. Children born to mothers vaginally who are breastfed have a larger diversity of microorganisms compared to babies born by C-section and who are formula fed. Breast milk really is this magical formula that acts as a superfood containing live cultures or probiotics and complex carbohydrates that acts as prebiotics or food for the gut microbes. The microbiome then develops its highest diversity when the transition is made to solid foods, and by the time a child is 2 to 3 years old, their gut microbiome resembles that of an adult. So exactly how do these gut microbes work? So when our beneficial gut microbes, let's call them probiotics, encounter fiber, or food for them is prebiotics in the form of whole plant foods. They digest and produce a byproduct called short-chain fatty acids. The short-chain fatty acids travel and communicate with different systems in our bodies. The three most important short-chain fatty acids are acetate, propionate, and butyrate. Short-chain fatty acids are the primary energy source for the cells that line the inside of the colon and aid in the regulation of several processes within our body. They protect the mucus layer lining the gut. They act in fat deposition. They act in inflammation and in immune system regulation. Just like short-chain fatty acids are these beneficial products produced by our gut microbiota, we also have products that are not as beneficial. These are called TMAO. Western-style diets are typically high in saturated fats, which stimulate the production of pro-inflammatory cytokines and a byproduct called TMAO, or trimethylamine oxide. This is produced by the gut microbiota when they ingest L-carnitine. This comes from red meat, supplements, and energy drinks, and when they ingest choline from red meat, liver, egg, and dairy. TMAO has been associated with increased risk of type 2 diabetes, heart disease, Alzheimer's disease, chronic kidney disease, and a host of other diseases. And studies show that people who actually consume a plant-based diet house a microbiota that is not capable of producing TMAO. So now let's talk about the epithelial layer. This is another way in which our microbiota protects us. And it's through the creation of a mucus layer to line our intestinal wall. The intestinal wall serves both as a barrier and as an interface between the rest of our bodies and our gut microbiome. It keeps harmful pathogens out while allowing beneficial products in. The wall is made of epithelial cells and tight junctions that keep these cells together and that seal it from the outside world. On the inner lining of the gut lives our intestinal flora, which reinforces this cellular wall structure through tightening its tight junctions through short-chain fatty acids and by lining the intestinal layer with a layer of mucus. So what happens when there's a disruption in our gut microbiome? This can happen through lifestyle measures such as poor nutrition or through antibiotics. Then what happens is that pathogenic bacteria take over and create an imbalance or dysbiosis. The layman's term for this is leaky gut. This results in a disruption of our intestinal layer through loosening of these tight junctions we just mentioned, which in turn allows harmful microbes and their products to enter our body through the bloodstream and lymphatic system. If our microbiome is disrupted for long enough, it causes a disruption of the mucus layer as well. This cascade leads to harmful microbes entering our body and causing inflammation and an altered immune response. A Harvard study published in the journal Nature in 2014 showed that a change in one's diet was quickly reflected in the person's gut microbiome, generally within a matter of days, which is incredibly surprising at that time. A diet high in animal protein quickly led to the microbiota changing to bile-tolerant microorganisms such as Bacteroides and Bilophila. In this animal-based diet, an increase in Bilophila wadsworthia was seen, which supports the link between an increase in bile acids, dietary saturated fat, and growth of organisms capable of triggering inflammation in the gut. So what's the good news? The opposite also was true. A change to a plant-based diet results in a quick change to the gut microbiome, and beneficial microbiota appeared and reversed the above inflammatory process. So what's our takeaway? The standard Western diet is naturally low in fiber. In fact, 97% of Americans are not getting enough fiber. And it's also rich in animal proteins, processed foods, and processed sugars. So by overfeeding our gut microbes with processed foods and fats and not feeding enough fiber-rich whole plant foods, we are creating a hostile environment within our gut and a breeding ground for inflammatory and disease-causing microbes. But the body is resilient, and our gut microbiota even more so. Because their lifespan is so short, in 24 hours of eating well and taking care of our bodies, we can have an effect on 50 generations of microbes. A change in our daily food consumption practices causes a drastic change in our gut microbiome. In terms of our health and our microbiome, there are areas where we have control and others where we don't. Where we don't have control is over genetics, anatomy, delivery mode, whether it was C-section or vaginal, and aging. But we do have control over lifestyle factors. Early feeding, whether it was breast milk or formula, medication and supplement use throughout our lives, nutrition, exercise, stress, mindfulness, and the environment in which we live. Optimizing our gut microbiome. So how do we do this? I mean, I just told you that the gut microbiome is an entire ecosystem. So how exactly do we get it back into shape? So first and foremost, the most important thing is to eat a plant predominant diet. The goal is 30 diverse whole plant foods per week. That's the magic number that has been associated with increased microbial diversity and optimal health. Second, get enough sleep. 7 to 8 hours of restful sleep is optimal. Practice mindfulness and de-stressing techniques. Developing coping strategies for stress management is essential to our gut health. Move more. Exercise is an essential part of health overall, and especially our gut health. Social connectivity. We often dismiss this, and during these times, it may be hard to connect with loved ones. So make sure that during these times, you're doing everything you can to stay connected with your loved ones. Second to last is connection to nature. We also dismiss this one as not being super important, but exposing ourselves to different environments, different natural environments, is essential to our gut microbiome. Things like being in the ocean, going out for a hike, all these influence our gut microbiome, especially if we sit down, we feel that dirt under our fingers, and we breathe in the air. And lastly is to minimize or avoid toxic substances such as alcohol, tobacco, pesticides, and unnecessary medications and supplements. So I know I just gave you guys tons of information in a very short amount of time, but I know you guys are going to take some of the recommendations I gave you and start implementing them right away to increase your microbial diversity in your gut microbiome and optimize your health. Again, I'm Dr. Vanessa Mendez. You can reach me at drvanessamendez.com. I'm also on Facebook and on Instagram as Plant-Based Gut Doc. Blessings and goodbye.